Hi, good evening, friends. I'm Gourav Gupta and welcome all of you to the YouTube channel of BYJU'S Exam Prep. Now, friends, here at BYJU'S Exam Prep, we provide all our students with their end-to-end preparation so that they can achieve their desired goals. All right. Now, friends, once again, I welcome all of you to the next session in which we are going to discuss the plotting of different types of functions. Okay. Now, I hope you have been attending all the previous sessions that I have conducted. Okay, and if I'll talk about the last few sessions, basically yesterday. So yesterday we have seen plotting of functions. Yesterday we started with the plotting of graphs. So that was the first session in which I introduced very basic concepts of plotting. In yesterday's session, we have seen how to plot a linear function and a quadratic function in general. Okay. Also, we have seen some of the basic concepts which is related to the shifting of graphs. So we have seen how to plot the graph of f of x plus k minus k, or f of x plus k and f of x minus k if the graph of f of x function, any function, is given to you. Okay, so all these things we have already seen in yesterday's lecture. Now, the last thing that we did was the plotting of a quadratic function. Okay, and in that question, the quadratic function was given in the factorized form, and I promised all of you that in the next session, that is in today's session, I'll be teaching you how to basically plot a quadratic function when this quadratic expression is given in its general form and not the factorized form. Okay, now I hope all of you remember whatever we have covered in yesterday's lecture. So good evening, Kusum, Sonalika, good evening. So I hope all of you, Ruchi, good evening. So I hope all of you remember whatever we have done in yesterday's lecture related to the shifting of graphs. All right. Okay, so let's continue where we have left yesterday. In case anyone has not seen yesterday's lecture, please go to it. So the name of the lecture was Plotting of Functions number 1, and we have learned how to plot linear and quadratic functions and in general the shifting of graphs. So let's continue. So let's start with plotting the graph of a quadratic expression which is given in general form. So ax square plus bx plus c. Ax square plus bx plus c is the general form in which a quadratic expression is given. Okay, so I have taken an example of x square plus 4x plus 3. Now what I'll do is, first of all, I will convert this expression into a perfect square form. All right, so I'll open a new page, x square plus 4x plus 3. This is given to us, x square plus 4x plus 3. And let's see the steps which can be used to convert this given expression in the perfect square form. Okay, so I'll be using the formula a square plus 2ab plus b square is equal to a plus b whole square. All right, now I already have a square and I will consider this as 2ab. Okay, so what I'll do is, I'll first of all take half of the coefficient of x. So जो भी आपको x का coefficient given है उसको half कर दो. So half of 4 is 2. Okay, and add the square of 2 and subtract the square of 2 to balance it, and plus 3 will be written as it is. I'll repeat. Now take the coefficient of x. Here the coefficient of x is 4. Half that number. So 4 divided by 2 is 2. Okay, 2 square will be added and subtracted, and 3 will be written as it is. Okay, now if you'll consider this portion can be written as x plus 2 whole square, then minus 4 plus 3. All right, now this is x plus 2 whole square minus 1. All right, so this is how we can convert any given quadratic expression into its perfect square form. All right, Darshit, it will be plus 4 and minus 4. So plus 2 square and minus 2 square. Okay. Hi, Vicky. Arpit, I'm good. Thank you very much. So friends, what I've done is I've converted the given quadratic expression into its perfect square form. I'll go back to the previous page. So I can write this as x plus 2 whole square minus 1. Okay. Now listen, now watch everything very carefully. So what I'll now do is I have to plot the graph of x plus 2 whole square minus 1. Okay. Now we'll use the steps that we have seen yesterday. We'll use the concepts which are related to the shifting of graphs in this particular case. Okay. So I'll start with the graph of y equal to x square. All of us already know what is the graph of y equal to x square. Okay. So I'll draw it with a dotted line. So this will be a rough sketch, a rough graph of y equal to x square, which will be passing through origin. Okay, again, please pardon my sketching, pardon my drawing. Okay, so y equal to x square, it will be an upward opening parabola that will be passing through origin. All right, now from here, if I want to obtain the graph of y equal to x plus 2 whole square, then what will happen to this graph? Okay, what will happen to this graph? This is what I want to hear from all of you. Come on, what will happen to this graph? I am given the graph of y equal to x square and I am plotting the graph of y equal to x plus 2 whole square. I'll again take you to the next page, the blank page. Okay, and let's see what will happen. So the graph of y equal to x square was given. This I can say that is equivalent to the graph of y equal to fx. I am plotting the graph of y equal to x plus 2 square. So instead of x, we have substituted x plus 2. So this is similar to plotting the graph of y equal to f of x plus 2. All right. Now this is similar to the cases that we have done yesterday. So whenever you want to plot the graph of y equal to f of x plus 2, in this case, the graph will shift, the entire graph will shift towards left. No, Siddharth, I think you have missed yesterday's lecture. So in this case, the graph will shift by 2 units towards left hand side. Okay, so the original graph whose axis was at 0, 0, now it will shift leftwards. So it will come here and the graph entirely will shift by 2 units towards left hand side. Okay, so let me draw the new graph with a green color. Okay, so the new graph will be something like this. Okay, so all of you can visualize, can view this green curve. Okay, so this will be the new graph. All right, fine. Now let's take one more step ahead. Now I already have the graph of y equal to x plus 2 whole square with the green color. Okay. Now let's have a look at the next graph. Graph for y equal to x plus 2 whole square minus 1. Okay. Now tell me what will happen to this graph. Come on, tell me. So I already have this graph. So let's say you are given y equal to x plus 2 whole square. Consider that this is the graph for y equal to f of x. Okay. And I want to plot the graph of y equal to x plus 2 whole square minus 1. So this is similar to plotting the graph of y equal to f of x minus 1. Now in this case, exactly Satyam, wonderful. The graph will shift downwards by 1 unit. Okay, so the graph will shift downwards by 1 unit. So the axis will become this point. I have shifted the graph downwards by 1 unit. Let me take a proper color pen. Wait. So let me use this one so that it will be visible. So this blue dot will be the axis. Graph will shift completely downwards by 2 units. And this is the new graph that I'm plotting with blue color. Okay, so graph will shift downwards by 2 units. And this will be the final graph of y equal to x plus 2 whole square y equal to x plus 2 whole square minus 1. So now I can say that the final graph of x square plus 4x plus 3 is the graph that I have drawn with blue color on these coordinate axes. Okay, so this is the step-by-step procedure of plotting the graph of a quadratic expression which is given in its general form. Okay, so yesterday we have just seen the concepts. Now we are looking at the applications of all those concepts that we have learned yesterday. Okay, fine. So this will be the rough shape of the graph of this quadratic expression, right? All right, now let's move ahead. Now, since today's topic is modulus functions, so let's slowly move towards modulus functions. Okay, so now let's talk about reflection of graphs. I'm not straight away moving towards modulus functions, so let's do it slowly and covering each and every concept, right? So first thing is reflection of graphs. So let's say you are given the graph of y equal to f of x. You are given the graph of y equal to f of x, all right, and you want to plot the graph of y equal to minus f of x. So what you have done is you have multiplied the entire function with a minus sign. Okay, so we can say that since we have applied a negative sign in front of the entire function, so we will have a negative sign in front of every value of y. So I can say that the values of y which were positive, the values of y which were positive earlier will now become negative, and the negative values of y will become positive. Okay, I repeat, the negative values of y will become positive and positive values of y will become negative for the same values of x. Okay, so we can say that the portion of the graph which is above x-axis, the portion of the graph which is above x-axis will be reflected and it will go below x-axis and vice versa. So let's have a look at this particular thing practically happening. Okay, so we can say that now the graph, original graph y equal to f of x will reflect completely along the x-axis. So x-axis will act like a mirror. So whatever the graph is, it will be completely reflected along x-axis, right? We'll look at it practically. So let's say these are the coordinate axes, and let's say the original graph was something like this. Let's say the original graph was something like this. So this is the graph of y equal to f of x. All right. Now I want to plot the graph of y equal to minus f of x. So this graph will be completely reflected. Yes, Satyam, it will be a mirror image. Good. So this graph will be completely reflected along x-axis. Okay. Or you can say that it will become a mirror image. So the new graph will be something like this, a proper mirror image of the original function. Okay, so the blue graph will be entirely removed and the graph for y equal to minus f of x will be like this. Am I clear? Yes or no? Understood? Okay, so y equal to minus f of x, the graph will be reflected along x-axis. All right, so I can say that the portion of the graph which is above x-axis, will reflect along x-axis and will come below the x-axis, and the portion of the graph which is below x-axis will reflect and will come above the x-axis. Okay, so this is when I'm plotting the graph of y equal to minus of fx. All right, okay. Now similarly, let's talk about what will happen if I want to plot the graph of y equal to f of minus x. Okay, so in the similar manner, the graph will be reflected along y-axis. Okay, so if y equal to fx is already given and I'm plotting the graph of y equal to f of minus x, the graph will be reflected along y-axis. So if the original graph was like this, if the original graph was like this, then the new graph will be reflected along y-axis and it will become like this. Okay, just a rough shape of this graph. Okay, Vicky, water image, mirror image, theek hai. So you call it water image when you have reflection along horizontal axis. You call it mirror image when you have reflection along vertical axis. That's absolutely fine. Yes, so more precisely, it will be a water image earlier, and this one we call it a mirror image. But I'm using the simple word reflection. Okay, so a complete reflection along x-axis or y-axis are the words that I'm using. Okay, so for y equal to f of minus x, the case that is in front of you, the graph will be reflected completely along y-axis. So this is the graph for y equal to f of minus x. All right, great. Now let's move to the next part. Again, reflection of graph, but in this case, I'll be considering the modulus function. So let's see what will happen if I will take the modulus of the entire function. That means if I'm taking modulus of entire function, that means I'm doing the modulus of all the values of y. ठीक है? So y equal to f of x, let's say this is given to us, and I want to plot the graph of y equal to modulus of f of x. So the entire function f of x will now go in the modulus sign. So what will happen here now? Modulus function karta kya hai? Modulus function, what it will do is, if you will give an input as a positive value, the output will remain same. So if I have a positive input, the output will remain same. But if the input is a negative number, then it will make it a positive number. All right, simple. Output will always be a positive value. So अब यहाँ पे क्या होगा? The values of y which were positive will remain as it is, and the values of y which were negative will become positive. So that means the portion of the graph which was above x-axis will remain as it is, and the portion of the graph which was below x-axis will be reflected and it will come above x-axis. So what I call it a partial reflection along x-axis. So the original graph of y equal to f of x will reflect partially along x-axis. ऊपर वाला पोर्शन ऊपर ही रहेगा, नीचे वाला पोर्शन रिफ्लेक्ट होके ऊपर आ जाएगा. Okay, so let's take an example for this. So if the original graph is something like this, okay, if original graph is something like this, then the new graph I'm drawing with red color. So new graph, so first of all, the portion of this graph which is above x-axis will remain as it is. So this portion will remain as it is, and this portion will remain as it is. Okay, and the portion of the graph which is below x-axis, it will be reflected and it will come above x-axis. So the new graph is what I have drawn with the red color. Okay, so blue wala graph completely gayab ho jayega and you will have a red graph. Yes, Vicky, positive vibes only for modulus. Great. Okay, so this is what will happen for the modulus function. The portion of the graph which is above x-axis will not change, and the portion of the graph which is below x-axis will reflect along x-axis and will come above x-axis. All right, so this is what happens with a modulus function. Okay, now let's have a look at different types of modulus functions step by step. Okay, so the general form of any modulus function can be like this. So this particular type of question may appear in your examination. Plus की जगह minus sign हो सकता है. All right, so let's start with the first one. When the function is of the form y equal to modulus x. So what I do, so this is a very easy question. Y equal to modulus x, all of you would know how to draw the graph. So this is a general graph for y equal to modulus x. Okay, but I will tell you certain different technique which will be helpful for the next few questions. Okay, so let's have a look at it. Now whenever you want to plot a graph of such a function, remove the modulus sign and plot the graph of y equal to x. Okay, so the graph of y equal to x will be something like this. It will be a straight line at an angle of 45 degrees passing through origin. Okay, so the line will be like this, right? Okay, now if you will take modulus of this entire function, so let's say this was f of x, which is equal to y, and the function was x. So if you will take modulus of this entire function, if you will take modulus of this entire function, that means I'm going to plot for this function, so it will become modulus of x. Okay, so now when we take modulus of entire function, what happens? The portion which is below x-axis will be reflected and it will come above x-axis. Okay, so the new graph will be, this portion will remain as it is, okay, and the portion which is below x-axis will be reflected, will be removed, and it will come above x-axis, and the graph will be like this. So the final graph will be like this, right? So it will be a V-shaped graph, you can say that. Okay, so this is something general about y equal to modulus x. Now let's apply this particular thing in some other questions as well. Now I want to plot the graph of y equal to modulus of 2x plus 6. So I'll start by plotting the graph of y equal to 2x plus 6. Okay, this we all know will be a straight line. So we'll start with y equal to 2x plus 6. So let's plot this straight line. Putting x equal to 0, the value of y will be plus 6. Putting y equal to 0, the value of x will be minus 3. So this will be the straight line which is passing through these 2 points. So let's draw a dotted line which is passing through these 2 points. Okay, so this is the graph for y equal to 2x plus 6. All right, this is the graph for y equal to 2x plus 6. Okay, now we have to plot the graph for y equal to modulus of 2x plus 6. Now since again I have applied modulus sign with the entire function, so the same thing will happen. The portion of the graph which is below x-axis will be reflected and it will go above x-axis. So the portion which is above x-axis will remain as it is. So this will remain as it is, and the portion which is below x-axis, it will be reflected, and the new graph will be like this. Okay, so portion below x-axis, I'm going to remove that. So just ignore the red part, and the final graph will be a V-shaped graph again, but obviously having different slopes as compared to the previous function. Okay, fine. So this is for y equal to modulus of 2x plus 6, right? Now let's take another variation for this. We already have y equal to modulus of 2x plus 6. Let's say now I want to plot the graph of y equal to modulus of 2x plus 6 minus 2. Okay, so we in the previous case had already reached to this part. Okay, we already reached to this part where the graph was something like this. Okay, so this was the original graph, right? So this was the original graph in the previous case. Okay, now what will we do? What will we do now? Vicky, you are asking other line will pass through minus 6 comma 6. No, Vicky, it will not go downwards. So this is the entire graph. That's it. This is the entire graph. Okay, Vicky? So now in this case, if I'm already given this graph and I want to plot the graph of y equal to modulus of 2x plus 6 minus 2. So what will happen to the original graph to obtain the new graph? Come on, tell me. What will happen to the original graph? What type of shifting will happen? Upward, downward, left or right? Come on, tell me. So I can compare it with y equal to f of x was given. and we are plotting for y equal to f of x minus 2. Okay, so Vicky, in this case x की जगह x minus 2 सब्सिट्यूट नहीं किया है, मैंने पूरे फंक्शन में subtract किया है minus 2. Okay, so this graph will shift downwards. So earlier the axis was here, now it will shift downwards by 2 units and the axis will come here. Okay, fine. So the entire graph will shift downwards and the new graph will be parallel to the original graph, but it has already shifted by 2 units in the downward direction. Okay, so this point will be minus 3 comma minus 2. All right, fine. So it will shift downwards by 2 units. Am I clear? So we have seen how to plot the graph of this function y equal to modulus of 2x plus 6 minus 2 using different steps. Okay, so now all of you will be able to plot this particular graph in one go. Let's move ahead and look at some different examples. So now I have to plot the graph for y equal to 5 minus modulus of x plus 2. Okay, now in this case I'll start with y equal to x plus 2. We'll start from here, right? Now y equal to x plus 2 से start करेंगे. So let's plot this straight line. So x equal to 0, the value of y will be 2. Y equal to 0, the value of x is minus 2. So this is the line which is passing through these 2 points. So I'll quickly draw this line. Okay, so this is this line. Now let's take modulus of this. So y equal to modulus of x plus 2. So again partial reflection along x-axis will happen. So portion which is below x-axis will go above x-axis, and the new graph will be with this bold red line. So this will be the new graph. Alright, something like this. And I am removing the portion which is below x-axis. Okay, so this is the graph for y equal to modulus of x plus 2. Now next step is we'll plot the graph of y equal to negative of modulus x plus 2. So मैंने क्या किया, इसके आगे माइनस अप्लाई कर दिया, इसके आगे माइनस अप्लाई कर दिया. Okay, so this graph will be completely reflected along x-axis. So reflection will happen, complete reflection will happen along x-axis. So जो भी ऊपर है x-axis के वो नीचे चला जाएगा, नीचे वाला ऊपर आ जाएगा. Now since this graph is completely above x-axis, so the new graph of y equal to negative of modulus x plus 2 will be like this. I'm drawing this with green color. Okay, so this will be the rough shape of this graph. All right, and the portion which is above x-axis will be removed. So let's remove this part entirely. All right, and the point from which it will pass will be this point, that is 0 comma minus 2, and this point which is minus 2 comma 0. Now finally what will happen, y equal to, अब मेरे को क्या करना है, 5 ऐड करना है, 5 minus modulus of x plus 2. Okay, 5 minus modulus of x plus 2, that means 5 is added. So this graph will now be shifted upwards by 5 units. So ये जो point है minus 2 comma 0, this will become minus 2 comma 5, and graph will shift upwards by 5 units. Okay, so it will be drawn parallel to the original graph, but it will shift upwards by 5 units, right? So this will be the new graph, or this will be the final graph of y equal to 5 minus modulus of x plus 2. Now Siddharaj is asking something, sir, the time in CAT is very less for the questions, so it will be feasible. Okay, now Siddharaj, if you are looking at all these things for the first time, obviously it will take a little bit more time, a little bit extra time for you to solve all these things. But with due practice, you will take less than half a minute to make the graph of a function like this. Okay. Also, we are learning to plot the graph of these functions so that we can answer to some other type of questions which are based on maxima and minima, finding maximum and minimum value of these functions. Okay, so Siddharaj, in my sessions, I am teaching you all the basic things. Okay, and definitely in CAT, they will not ask you to plot the graph. Okay, in CAT, they will not ask you to plot the graph. These graphs will be indirectly used in different types of questions. Okay, so we are just learning the basics behind all these things so that our fundamentals are fine and we'll be able to apply all these things properly. Okay, fine. Now, Vicky, repeat the last 2 points. So, Vicky, basically, in after this, what I did was I plotted the graph of negative of modulus x plus 2. Okay, so graph was above x-axis and it was shifted below x-axis. So, basically, this was the graph of negative of modulus x plus 2. Okay, after that, I added 5. So if you will add 5 to the entire function, the graph will shift upwards by 5 units. So the new graph, this, which is little above x-axis, okay, this is the final graph of 5 minus modulus of x plus 2. Okay, all right, fine. Now let's move ahead and look at the next thing. How to plot the modulus of quadratic expressions, quadratic functions. So first of all, this quadratic function is given in its factorized form. Okay, so I'll plot x minus 3, x plus 2. I'll remove the modulus sign. Okay, so x minus 3 into x plus 2. This particular graph will have roots as plus 3 and minus 2. Okay, and the shape of the graph will be a parabola, which is an upward opening parabola, okay, and passing through minus 2 and plus 3. Okay, so this will be the rough shape of the graph. All right, now if I'll take modulus of this function, so modulus of x minus 3 into x plus 2. So again, all of you know what will happen. So the portion of the graph which is above x-axis. So I'm marking this graph with the green color. So the portion of graph which is above x-axis will remain as it is. This portion again will remain as it is. And the portion which is below x-axis will be reflected and it will come above x-axis. Okay. So the red graph will be totally erased. The red graph will be completely erased. And what is left will be the green graph, which is the graph for y equal to modulus of x minus 3 into x plus 2. Right? So yesterday we have seen how to plot the graph of such functions. Now today we have done the modulus of all these functions. Okay? Moving ahead, taking one more example, again that we have seen yesterday. So first of all, I'll plot for y equal to 3 minus x, x plus 2. I'll take negative sign outside. Okay, so basically this is nothing but x minus 3 into x plus 2 with a negative sign. All right, so if I'll plot the graph of this one, so it will pass through x equal to plus 3 and x equal to minus 2, and it will be a downward opening parabola. Okay, it will be a downward opening parabola. So the rough shape of this graph, yes, Siddharth, so gradually we'll go there. Don't worry. So I cannot, Siddharth, understand one thing. I cannot directly jump to a higher level thing. Okay. So please be patient. So let us first of all finish this. We'll gradually climb up the ladder. So the graph of this function will be a downward opening parabola, which will be passing through minus 2 and plus 3, something like this. Okay. Now, if you take modulus of this function, if you'll take modulus of this function, that means y equal to modulus of 3 minus x into x plus 2. Okay, if you'll take modulus of this function, then the portion of the graph which is above x-axis will remain as it is. So this portion will remain as it is, right? And the portion which is below will be reflected. Okay, so the green part will be reflected and the new graph will be something like this. Okay, right? Siddharth, getting all these things? All right, let's move ahead and look at the next part. So ये बहुत easy है. So here I'll start with y equal to x square. So y equal to x square, the graph will be something like this, passing through 0, 0, passing through origin. Then I'll move to y equal to x square minus 4. Okay, so y equal to x square minus 4, the graph will be shifted downwards by 4 units. 1, 2, 3, 4. Okay, so graph will be shifted downwards and the new graph will be wait. So I'm just drawing the rough sketch of these graphs. Okay, so new graph will be like this. All right, and if you'll take the modulus of this function, that means y equal to modulus of x square minus 4. So if you take modulus of this function, again the portion which is above x-axis will remain as it is and the portion which is below x-axis will be reflected and the graph will be like this in the green color. Okay, so the red graph will be completely removed and this is what you'll be left with. All right, great. Now further the same thing from where we started, y equal to modulus of x square plus 4x plus 3. So y equal to x square plus 4x plus 3. So how did we converted this one to a perfect square? It was x plus 2 whole square minus 1. Okay, so I am plotting the graph for y equal to x plus 2 whole square minus 1, which we have already seen at the beginning of this class. So we started from this one, right? So first of all, y equal to x square was shifted towards left, okay, and then shifted downwards by 1 unit. So it was first shifted towards left by 2 units and then shifted downwards by 1 unit. So the original graph of this function will be something like this. Wait. So it will be something like this. Give me a second. All right. Okay, so this will be something like this. An upward opening parabola passing through minus 2 comma minus 1, right? And if you will take modulus of this entire function, y equal to modulus of x plus 2 whole square minus 1. Now all of you know what will happen. So this is what will happen with this function. Okay, so this will be in blue, in red color, the final graph of this function. All right, okay. So friends, this is about modulus functions. Okay, now the last question for the day, plotting the graph for mod x plus mod y equal to 4. Okay, now this is the type of question. So Siddharth, this is the type of question that we get in our examinations. Okay, now how to plot them very quickly. So if we understand the basic shape of this graph today, then it will take hardly 5 seconds for us to plot the same thing in the examination. Okay, now in this case I have modulus x as well as modulus y. Okay, so now I'll be going back and looking at the basic definition of modulus function. Okay, now this graph will react in a different manner in different quadrants. So if I look at quadrant number 1, mod x plus mod y equal to 4. In quadrant number 1, since both x and y are positive, in first quadrant, since both x and y are positive, so modulus x will be x and modulus y will be y, and the right hand side will be 4 as it is. So in quadrant number 1, this particular equation will become x plus y equal to 4. Okay, so let's plot this in the first quadrant. So x equal to 0, y will be 4, and y equal to 0, x will be 4. So in the first quadrant, the graph will be a straight line like this. All right, okay. Now let's enter the second quadrant. Second quadrant. Now mod x plus mod y equal to 4. Now if I talk about second quadrant, in second quadrant, x is negative. Okay, so modulus x will become minus x. Y is positive, so modulus y will become plus y. And on the right hand side, it will be 4. Okay, so in this case, if I'll plot this in the second quadrant only, putting x as 4, y will be equal to, putting x as 0, y will be equal to 4, and putting y as 0, x will be equal to minus 4. So the line will pass through these 2 points, and the equation, the graph will be like this. Okay, let's move on slowly and slowly. Now next part, in the third quadrant, modulus of x plus modulus of y equal to 4. Now in the third quadrant, since both x and y are negative, so modulus x will become minus x, modulus y will become minus y, and on the right hand side it will be 4. Now putting x equal to 0, the value of y is negative 4. Okay, and putting y as 0, the value of x will again be negative 4. Okay, so the graph will be like this in the third quadrant, and finally in the fourth quadrant, mod x plus mod y equal to 4. X is positive and y is negative, so mod x will become x and mod y will become minus y, and finally equal to 4. So putting x equal to 0, y will be negative 4, and putting y equal to 0, x will be plus 4, and join these points like this. So this is the entire graph for mod x plus mod y equal to 4. Vicky, this is not a 4 cross 4 square, though this is a square, but this length will be 4 under root 2. Okay, this length will be 4 under root 2. This length is not 4, this is 4 under root 2. Okay, please take care of this thing, right? So if basically we had to find out the area of this region, area of this portion which is enclosed, so you can either say that this is a square of side 4 root 2. So 4 root 2 multiplied by 4 root 2 will be the area. So area will be equal to 32. Or you can consider the diagonal. Okay, what is the length of the diagonal in this case? So this is the diagonal. So length of the diagonal is 8. So using diagonals, the area is half d1 into d2. We will cover geometry as well. So half d1 d2, that is half into 8 into 8. All right, and again area will come out to be 32. Okay, so this is the general type of questions that are asked in our examinations. So they'll give you a graph like this, they'll give you an equation like this, mod x plus mod y equal to 5, equal to 6, or whatever, and they'll ask you to plot the graph of this function, or they'll ask you questions which are related to the graph of this particular function. All right, fine. Vicky, no, this is, so Vicky, yes, I have applied the area of rhombus. Rhombus, I can say that every square is a rhombus. So square के case में भी हम ये वाला formula apply कर सकते हैं. In the case of square, the area will become half d square. Okay, half d square will be the area using diagonals because both the diagonals are equal, right? Fine, friends. So let's stop here for the day, and with the discussion on the agenda that I'm going to take, going to take tomorrow. So tomorrow I'll be taking you through the graphs which will cover certain region. So graphs of inequalities. Tomorrow we are going to have a look at graphs of inequalities. All right. So I hope all of you will be present tomorrow. If you liked today's session, please do press a like button quickly. Do leave any comment in the comment section. Okay, share this session with your friends and do subscribe our channel. Now this is the schedule that we follow for the entire week on YouTube channel of BYJU'S exam prep. Now friends, in case you want to join any of the programs, online classroom programs at BYJU'S, so this is a flat 25% off which is going on right now. So you can call at this number for further details and you can apply this code to enroll yourself. Also, we have just started with a crash course, a 2-month crash course for all the students who are preparing for CAT 21. All right. Now, these are the complete details and the list of faculty. So I'll be among one of the faculty in this batch who will be teaching Quant here. Okay. Now, another batch for CAT 22, a complete course, batch number 5, which we have started. So these are the complete details for that particular batch for the aspirants of CAT 2022. Again, people who are taking CAT 2021 as a target, please do register. Please do not miss All India Open Mock, which has already started yesterday and it will go up till 4th of October. So please do enroll for this paper and take your preparation to the next level. Now these are different courses for CAT and other MBA examinations that we offer here at BYJU'S Exam Prep. Certain online classroom programs for CAT 21 and CAT 22 are mentioned on the screen. The list of mentors that we have on our panel. That's all from my side, my dear friends. Please do follow us on Instagram and Facebook and join us on Telegram. And do subscribe this channel. Thank you very much.